all here. Well, thank you for coming. I know it's a bit early today, but we have a full day packed of lots of good things. We're excited to be bringing back DevIgnition after a few years, a little bit in hibernation thanks to COVID, but we're back and we're very excited about it. So this morning, before we get into the talks, just want to do some housekeeping things. Right now, obviously, it's a bit small, so if you guys want to move forward, we can have a little bit more engagement, so don't be afraid. Please move to the front of the room. Please move. I highly recommend it. Brian is not going to do anything crazy or put you in a splash zone like you're at a SeaWorld show. I promise. So thank you. Other thing I wanted to mention too is the Wi-Fi. I know a lot of us love Wi-Fi and it's a little confusing here. So what you do is when you look at the different networks, it's Mason, and then it'll pop up with a window and ask you, log in with your account. We obviously don't have accounts unless you're a student here. So just feel free to make a free one and then it gives you a PIN, you log right in and you're hooked into the Wi-Fi. Super simple, right? Thumbs up? All right. So, first up this morning, we're really excited for our keynote, I believe, right? Brian Childress, he's from a faraway place called Richmond. Anybody ever heard of it? Oh, good. We got 2 people. That's good. We're making progress. But Brian is CTO at Fractional. He does a lot in the technology community here, especially in the DMV. So I'm very excited. I've seen him speak Frontrunners. How many of you have been to Frontrunners before? Good stuff. Yeah, you should come check that out in, what is it, February, I believe? That's focused on the JavaScript community. So, March. Whoops, I'm giving bad info. I will correct that. It is March, not February. But feel free to wait for that when it comes out. But Brian Childress is coming back to us today, and I will let him take it away from there. So please give it up for Brian Childress.
Thank you, Katie. All right, good morning. Thriving in a connected world. I know over the last several years, things have really changed for many of us in how we live and work. And today I'd love to dive a little bit deeper into some of the things that I've found work well for working in this kind of new way. But before we get started, as Katie mentioned, it is very early. I do want us to kind of make sure that we are alive and awake and ready to pay some attention. So don't have to get up, but please just kind of stretch, move around, get a little movement going, get the coffee flowing through our veins a little bit. Everybody, this is an interactive session. Participation is required, so please help me out here. As you heard, my name is Brian Childress, and I am from a small suburb of DC known as Richmond, Virginia. I've been there for a few years with my family now, and really enjoying the tech scene there and up here in DC. Now, I work as a fractional CTO and technical advisor, which is basically just a very confusing title to say that I have the opportunity to work with a number of different companies, startups and scale-ups, helping them to grow and scale not only their platforms, but their teams as well. Now, my goal for this talk is that I can share some insights as an engineering leader, and hopefully folks that are not leaders, but are individual contributors, are able to take some valuable information away as well. So now I've had the opportunity to work in a distributed environment or in a remote team for pretty much my entire tech career. A quick kind of map of, these are a lot of the places where I've worked with other team members, other engineers. So I've really found a lot of benefit in working in this way, but there are certainly a lot of challenges when you're working with people really spread across the globe. Who here has worked in a distributed or a remote environment, a remote team before, say, maybe like early 2020? Has anyone ever done that? Yeah. So the COVID pandemic really thrust a lot of folks right into remote work, and there's a lot going on at that time, right? A lot to try and figure out. Companies weren't quite sure how to go about working remotely. And I think one of the challenges that I see a lot is we try and shift the way that we work in an office with others to do the same thing remotely. So we have the same meetings, we have the same expectations for speed of communication, and unfortunately, in a distributed or a remote environment, it can be very, very taxing for us trying to get our work done. Well, why do we go with distributed? What are some of the benefits of it? So for one, I think we now have access to global talent. We're no longer restricted to trying to find talent just in our region, folks that can commute to the same office. We can now look in other states, other time zones, and completely different countries. And this has been a really, really big benefit because now we have access to experience and expertise that we haven't had before. One of the other things that we hear a lot around the benefits of working in a remote or a distributed environment is that we have access to cheap labor. And I really don't like thinking of it that way, but I do think that we do have not only access to great talent, but folks that live in lower cost of living countries. This is really, really beneficial because now we can pay for fantastic talent, and folks in those other countries are able to make a really, really solid wage. And then finally, I think that one of the biggest benefits in really adopting a distributed culture is that now we are able to actually create time because we have access to more time zones. So way back in the day, we used to call this the follow the sun model, where we would have different teams in different regions of the world. They would start their day normally, and then there would be project handoffs throughout the day. So that really we were able to work on a project for effectively all 24 hours of the day, pushing things forward. I think there's a lot of benefits to this. Certainly doesn't come without its challenges. Now, real quick, does it feel like time zones and understanding time zones and getting time zones right feels exactly like trying to catch a rocket out of midair? Yeah. Super confusing. It's very, very difficult. So when I think about how do we work within the different time zones? How do we take the benefits of them without adding additional confusion? I think it's important to establish, hey, what is the time zone that we're talking about now? If we have to have a synchronous meeting, let's make sure that we're all on the same page for which time zone that we're actually in. And what are we talking about? Has anyone ever shown up late to a meeting because of the time zone? Maybe early, maybe not at all. Yeah, it's a big challenge, and it's something that, it's a very small thing, but as you're scheduling, as you're talking about it, it's important to just say, hey, we're going to meet in Eastern Standard Time. This is our time, and then everybody can kind of calculate. Anyone in here doing hiring right now? Anyone trying to find great talent anywhere, locally, remotely? Just me? Okay. So, hiring is a big, big challenge, right? It's challenging not only if we're hiring somebody who we can see face to face, shake their hand in person, but hiring in a remote environment is even more difficult. So there's quite a few stories that I can share about the different things that people are trying to do as they're applying for these remote opportunities. There are a lot of fake profiles that are being created, a lot of fake applications. We're seeing folks pretending to live in Gainesville, Florida, and when you start to talk to them in the interview, you realize they have no idea where Gainesville, Florida is or anything about it. But they are really trying their best to try and circumvent a lot of the interview process so that they can get into the organization, make a really good wage, and really it's really, really challenging. So one of the ways that I like to go about my hiring is what I call a test-first hiring approach. So we can do a lot of technical challenges and deep dive interviews, panel interviews. But at the end of the day, it's really hard for us to really know, is this candidate somebody who we want to work with, who actually has the skills and not is just great at interviewing. So when I think about test-first hiring, I'll put together a very small project, a very small or a short contract where we have an opportunity to now work together on it so that we can see, hey, is this person somebody that I actually want to work with day in and day out in this role? Is this person somebody that can do a great job at communicating, at collaborating? Do they actually produce high quality code if we're building software together? This is a really great way that we can reduce the risk of hiring somebody and increase the speed at which we can bring them on and start to really evaluate how do they fit within our organization. There are a ton of job boards out there where we can post a lot of the jobs that we're trying to hire for, and there are a lot of bad applications that come in. Like I mentioned, I'm seeing a lot of fake applicants coming in. So one thing that I prefer to do is to identify, hey, these are the roles that we're looking for, and then starting to do outreach. Again, now that I'm able to look outside of the bounds of, say, Richmond or outside of DC, I can now look more globally. I now have access to a bigger talent pool, but I like to reach out to folks that may not actively be looking for a new opportunity, but may be a great fit for some of the roles that I have. So some of the ways I do that personally is just using tools like LinkedIn and some of the other platforms that have already aggregated information about individuals. One of the big things that we need to do when we're in a distributed environment especially is really build trust, right? I'm no longer sitting next to the person that I'm working with. We're no longer on the same floor or in the same building, or heck, most of the time we're not even in the same state. So how do we build trust within our organization so that we can effectively work as a team? One of the things that I really like to do is, I have the benefit of working on a number of different teams with folks spread all over the world, from Lebanon, Ukraine, Poland, Uruguay, Arizona. There are a lot of great folks, and they have all different cultures. They have all different experiences and areas of expertise. So one of the things that I really like to do is to understand who they are and what their background is. What are some of the things that are important to them or unique to their culture? What are some of the holidays that they celebrate? Now, not necessarily every person in that particular country is going to celebrate the same holidays, but it's a really good way to start to build that connection, to build that understanding, because I'm interested in learning about who they are and what they think is important. Now, for a lot of the folks that I work with, English isn't their first or their second language. Typically, English might be their third or their fourth language. I'm fortunate to work with a lot of very smart people. And so, for me, as a way to try and build trust and build connection with the folks that I'm working with, try and learn some basic terms in their native language. Morning, thank you, please. Different ways that I can try and practice my southern dialect of some of these languages can really start to bring some of that connection together. And thankfully, they're very understanding, and they will help me to make sure that I'm pronouncing it correctly and not offending anyone. But I have found that that's a really good way for us to start to build a connection. So no matter where we're working, whether we're in person or remote, but especially in a remote environment where we're not sure what's going on or where we fit within an organization, we're at home in our home office and feeling very disconnected. What I've found is true is that everyone wants to know a few different things. They want to know, hey, how am I doing right now? How is my work being perceived? Am I communicating well enough? Are there areas that I can improve? What are the things that are important that I can make sure that I, as an individual contributor, can be focusing on? People also want to know, hey, what should I be working on? Because it's very easy for us as leaders to kind of forget about people. Like, oh no, I haven't talked to Kenny or Sally in a few days. How are they doing? How are they progressing? If there's not a culture of continuous outreach to make sure that someone is doing okay, we might forget about them, and they may be working on something that is actually no longer a priority for the organization. And then finally, I think one of the biggest things that we all like to know, whether we're an individual contributor or a leader in an organization, is what role does my work actually play in the bigger picture? And I find this to be really important to help illustrate for engineers when we're building a new form and we just have the same basic form fields, what role does this actually play in the organization? Why does it matter that I'm creating this thing? Because it feels so small and so insignificant in the moment. How do I know that the work that I'm doing is actually important and actually driving us forward? So as a leader, I think it's important for me to make sure that I know, hey, how does everyone know what's going on in the company and where we're headed? Again, because we're not sitting next to each other, we're not, going to lunch and grabbing coffee together the same way we did in an office environment, it's easy to lose sight of those things. We feel completely disconnected. And so it's important for us to always continuously be reiterating, where is the company going and what role does my work play in that? Who here is doing regular one-on-ones, either with their manager or with their direct reports? I think this is one of the most powerful things that in my career, I wish I had more of these as I was coming up through the ranks. I wish that my managers really would sit down with me and have regular one-on-ones where we could talk about my career growth, the role that I played in the organization, and how it was that I would be able to contribute and to continue to grow. Now for me, one-on-ones are a very important space, and I make sure that these are top priority for me and the team. So I want to make sure that I'm never going to cancel a one-on-one, and I'm rarely going to move a one-on-one. I schedule around them because I want to protect that time because I do think that it is so important. Now I like to tell my team that one-on-ones aren't necessarily for work talk, right? That's not where we're going to be doing status updates. That's not where we're going to be doing project planning or necessarily diving into deep technical topics. There are other meetings, there are other opportunities for us to collaborate on this. A one-on-one is the opportunity for me as a leader to make sure that the folks on my team feel supported, that they have a place to bring issues to me, that we can talk about their career growth and making sure that I'm doing my best to support them in that growth. Now, one-on-ones are, for me, a place to give and receive feedback. Now, the way that I structure my one-on-ones is, we have, once we kind of talk through our agenda items, I ask for, hey, what feedback do you have for me as a leader? And I sit back and I listen. And the only response I have is thank you. Because I want them to feel like they have the opportunity to really share what is on their minds and what feedback they have for me so that I am doing my best to support them as a leader. Now, I also think that one-on-ones are important for giving feedback. And every single one-on-one, I make sure that I give feedback to the person on my team. Every single time. I don't think that there's value in a one-on-one without giving feedback and growth opportunities. Now, one of the ways that I kind of manage this is I have 2 documents that I use. So every member on my teams will have a shared document, right? Like a Google Doc that I'll share with them. And that's their place to put agenda items. So the way that I structure it is at the very top, I have their personal and their professional goals that they've shared. I'll ask them, in 5 years, we can't work together. What are the goals that you have? Because I want to make sure that the work that we're doing down in the trenches every day is in some way pushing and driving towards some of those goals, both personal and professional. From there, we just have a simple agenda item. And this is a place for either one of us to drop some bullet points on the document that we can make sure we're hitting those topics. And this is my direct reports. This is their place to put those items. They own the agenda. I'm only there to support them. Now, the second document that I have is just internal for me. So anytime that I see a conversation happening in Slack, or someone responding in a meeting, or not responding in a meeting, or some sort of thing that it feels a little nitpicky, it feels like, maybe this isn't super important to bring up immediately, but it is something that I want to bring to their attention. that I can provide coaching on, I put that into a feedback document. So as soon as the person that I'm working with gives me their feedback, I'll pull from this document the feedback that I have for them, based on what I think is important for their continued growth. You guys remember a few minutes ago, hopefully you do, when I asked you to kind of move around in your chair. Most of you were really pretty worried that we were going to have some other weird icebreaker coming right behind it. Yeah. I did that for a reason. One, to try and liven up the room, get everybody awake. But it's also because if you think about it, did anyone do the same movement or have the same reaction as their neighbor? No. You all got the same information. You had the same request from me, but you didn't do the same thing. You interpreted it slightly differently. And one of the biggest things that I think is important for us to consider and keep in mind when working in a distributed or in a remote environment is around our communication. Right? I asked you one time, everyone had a different interpretation of that request, but maybe I didn't get out of it what I was looking for. Maybe the way that you interpret that information is different, and I need to reiterate it or to change the way I deliver it. I think communication is really, really important for us. Again, because I can't turn around to the person I'm working with and say, "Hey, Johnny," and ask a question. So a couple things that I found work really, really well is to have a culture of open communication and open collaboration. This is where we have shared documents that everyone has access to, that everyone can edit and collaborate on, leave comments on. This is really, really helpful so that everyone is aware and everyone is part of the conversation. They're able to get up to speed in their time, not necessarily the same time as me. I also really, really promote that we don't have a lot of collaboration in our direct messages, in our DMs. They just get lost to the sands of time, right? If someone leaves the organization, so does all of that information, and that conversation completely goes away. So I really encourage us to have things like project-based Slack channels or different ways that we can collaborate more in public, in the open, so that we are all aware of kind of what's going on, what information is there. Now, when we're working in this type of environment, one of the biggest differences that I've found is going from kind of the way that we always work in like an office environment to now is that we used to just say, send a quick message, "Hey, how's it going?" And then we would wait for that back and forth. So what would happen is I would send a message and then wait for that other person to see it and reply. So we always felt like we had to be watching Slack all the time or watching our email all the time. And that can be really, really challenging. We're constantly switching contexts. We're not fully paying attention. One of the things that I think is really important for us to give engineers and folks the space to be able to create is to give them all of the information that they need in order for them to do their work, to answer the questions that I have, so that they can do it in a time that's appropriate for them, so that they're not waiting for me to reply to give additional information. And give everything to them all at once. Because, again, not everyone's going to be working at the same time. So let's make sure that they have the information that when they're online, when they're working, that they're able to progress and move forward. Tools. We all said we struggled with time zones, right? One of the tools that I found to be really, really helpful is this website, worldtimebuddy.com. Very, very simple. Basically, you can put in the different time zones that you're trying to figure out and then find the time that aligns. You don't have to sit here and do the weird translations, especially when you're dealing with like folks in Europe or Latin America or something. Time zones get super weird, and I try not to figure that out anymore. I used to think this was a superpower. Who here is using Loom or some other like recorded video to like have async collaboration? Yeah. This has been a really, really powerful tool for me over the last few years because now I can record a quick video where I'm sharing my screen, I'm walking through something that I'm thinking about, and then I'm posting it out there for the rest of the team to consume. Right? I use this a lot for code reviews or architectural changes that I'm thinking about so that I can then get feedback from it. And what I find with recorded video like this is, one, it's a heck of a lot easier for me to communicate what I'm thinking, and it brings that human connection, that feeling like, oh, we're actually part of a team, and I'm not just on the other side of a Slack message. I'm actually feeling like I'm part of something. Now, Loom is a great one. Slack has also added a lot of very similar features recently, if you've seen them. So some of my teams really love to use things like audio messages. Just send a quick 50-second, hey, this is what I'm thinking message. Again, it gives us that human connection. It's easier for us to actually have that communication versus, I don't really want to write this long paragraph to try and explain this, so I'm just not going to. I found this to be really helpful, and Slack can do video as well, so just very short recorded videos have been really, really helpful. So we've got to track progress somehow, right? It doesn't matter whether we're in the office or completely spread across the globe. We've got to make sure that we're moving in the right direction. So one of the things that I like to say when we're tracking progress is, let's pick one tool that we use for project management, for task management. You know, you'll see like, oh, well, we put our bug reports in this Slack channel, and this team over here is using Google Spreadsheet. And for our engineering work, we have this Kanban board. That just gets really confusing because you don't know where to look. And being in a distributed environment, you don't necessarily want to go and ask somebody again, where the heck do I go and find this thing? So you don't ask, and you struggle, and you spend time, and you waste cycles trying to find the information that you need. Pick one tool and just go with that and drive all conversations and all communication and collaboration back to that point. One of the other things that I found to be really, really helpful is this idea of an end-of-day report. Basically, the way that I structure these on one of my teams is that we have a shared private Slack channel between me and the direct report. And we might add a few other people in, kind of depending on who should be aware of the information. And this is basically like, think of it like your end-of-day stand-up. Right? These are the things that I worked on. These are the blockers that I have, the challenges or the questions that I have. And then these are the needs that I'm like. And then so me, as a leader, I can go in and review that, make sure that we're continuing to move in the right direction, that we're making progress. And then if there is a blocker, let me make sure that I can remove that. And I found this to be a really good way to share that information and for us to not lose kind of track of what's going on if somebody needs it. Really quick, because I think we are right at time, just to quickly recap, being in a distributed remote environment, hopefully many of us have felt it over the last few years, but there are a lot of benefits that we can bring from it. Super important for us to build and to maintain trust. Because we're not sitting next to the same people that we're working with, it's really, really difficult to kind of know where we stand and to feel like we can trust the company or the environment or the team that we're on. Communication is absolutely key. This is one of the biggest things that I look for when I'm hiring and when I'm growing my teams is how well does this person communicate? Can they communicate? Can they collaborate well? There are a lot of fantastic tools out there. Otter and Fathom and Loom are great ways to record kind of what's going on so you can get AI summaries of meetings. There are a lot of really, really good tools out there, so I would encourage you to kind of play around with them and find the ones that work for you, your team, and your work with. And finally, I think it's really important for us to track and also celebrate progress. Right? We can all feel like we're just throwing more work into the proverbial pile. It's important for us to celebrate those small wins and really, really make a big deal about it so that we can continue to promote and bring everyone together, even if we're not physically. We have. All right. Question. Anyone have any questions? questions?
Someone's gonna have one question. There we go.
There it is.
You mentioned video messages. I wonder how well the search for them work. Because Slack for me is a great place to find old information, because I know someone wrote something way back in Slack and I can search for it, but I wonder if video has the same capabilities.
As far as I know and what I've seen, it does, because AI will do Slack will do an AI transcription of what's spoken about in the video, and then that transcription becomes searchable.
Excellent. New today.
Hi there, big fan. So I work at a really large organization, and we have a lot of silos, and each silo operates differently. We use different tools. My team uses Slack, the rest of the organization uses Teams, for example. How do you recommend how you use an environment like that, where everyone and every team uses something different?
Within your team, I think it's a little bit easier because you get to decide. You have kind of that full autonomy on what your tool chain is. Narrowing down those tools can be really helpful just within your team. If you have to start to cross-collaborate with some of the other teams and those effective silos, I think it's important to establish that early on. Say, hey, I'm having trouble communicating with you. I know you guys are using Teams, we're on Slack. What can we agree upon? And there has to be a compromise so that we all converge. And what I find is the smallest set of tools that you're able to use, both on your team and more collaboratively, the better. If you have stuff spread out all over, it just becomes a mess, especially when it comes to documentation and all that.
All right. Thank you, Ryan, so much. Let's give him one more round of applause.
Thank you all.
And if questions do pop up, Brian is hanging out still for a little bit, so feel free to ask him questions during our next break. Next up, I see we have Pratik Patel here, who's up front in his JVM hat, so he's fitting the vibe today. But for those of you who don't know, Pratik is coming to us from Atlanta, where he actually runs the Atlanta Java User Group, or JUG, as well as DevNexus. So I'm very excited to have him here today with us. So Pratik, I think we need to mic you though, so give us 1 minute. All right, let's give him a warm round of applause though. Great job.
Oh, is this thing on? Do you hear me? In just a second, you're plugged in here. It works.
Anybody know any good jokes while we wait? Really? Nothing? It really is a tough crowd this morning, man. Kill me. I should have worked on my dad jokes before I got here, I think.
All right, I think this is all set up. Good morning, everyone. How many people in here are Java developers? Just by a quick show of hands. Let me rephrase that. Who is not a Java developer? Okay. Why are you here? I'm just kidding. Just don't get worse from here, so you've been warned. let's get started. There's a break after this, right, Katie?
Yeah.
And I can use the whole break to do the rest of my presentation, right? Okay. Katie says that's what I could do, so that's what I'm gonna do. Okay, why not, right? It's a 30-minute break though, right?
Yeah.
Okay. I'll probably run into the break since we're getting started a bit late here. But if you have any questions while I'm going through this, please feel free to ask them at any point in time. Happy to take a pause and talk about whatever the current topic is. As Katie said, my name is I'm a Java champion based out of Atlanta. You may have read one of the books I've written. I work at a company called Azul Systems. We only do Java virtual machines. So for all the Java devs in here and non-Java devs, you probably know what a JVM is. We actually have a high-performance VM called Zulu that gets 150 million downloads, actually more now. It's completely free. It's our build of OpenJDK and our contribution to the community. And we also have a high-performance JVM called Platform Prime, which again is for high performance. And I'll talk a little bit about that during this presentation. But this is not a product pitch. This is talking about cloud cost optimization specifically for Java workloads. And we also have a really amazing next generation product called Code Inventory and vulnerability detection, which is one-time detection of vulnerabilities, and the code inventory part lets you know what code you're actually executing in production, which is amazing because if you're like every other software company or software shop, software team, you know that there's a lot of code that you don't actually run. But wouldn't it be amazing if you could find out what that code was and just get rid of it because you know you're not actually running it in production? Right? So I can talk about those out in the hallway after the presentation if you're interested. And one of the things about our high performance VM is that it is a drop-in replacement for OpenJDK or Oracle or whatever. And it gives you an instant performance boost just by swapping out the JDK. So for example, one of our customers, I can't tell you who they are, but they're the world's largest retailer and they end in Mart. You may have heard of them before. They're one of our customers. They dropped it in for Apache Kafka and saw a huge gains on it. Okay, enough of that. Let's start off with some questions. How many people are on the cloud or deploying stuff on the cloud today? So I expected less people here because, you know, the kind of things that happen in this area. Which cloud provider are you guys using out of curiosity? AWS, okay. You raise your hand also, right? Azure, okay. Anybody else? Anyone using GCP out of curiosity? Okay, one GCP person. Now I will say that even though this presentation is focused around cloud cost optimization, if you're running on-prem, you can still get the same benefit because as all of you know, servers and infrastructure and a data center and all that kind of stuff is not cheap. There's a lot of operational and capital costs that go into it. It doesn't really matter which cloud platform that you're using. What matters is how you use it and using it to the max. And the other side of that coin, of course, is using less of it to save money, even if you're running your own data set, right? It gives you more headroom and things like that. So the next question is, what's the best way to reduce cloud costs? Not a trick question. I have trick questions later. So, anyone want to take a quick guess? So of course the answer is turn off your service. This is a very small program, sorry about that. But real answer is it depends on your application because every application, as you know, is different. It'll have a different performance and usage profile, and we'll talk a little bit about that during this section. Give you an idea of what you can do to kind of make your application use the compute and memory power that you have underneath it to its maximum efficiency. Okay? And the other answer is that there is no one-size-fits-all solution. When I work with the Zoom customers and we look at how they're running their applications, whether it's on the cloud or on-prem or whatever it may be, the app, how it runs, what kind of performance characteristics it has, makes a big difference. And of course, what it's doing, bursting traffic and other things like that. But before we jump into that, I want to talk about cloud pricing for a few minutes. Okay. So here's a question for you. Does the cost of cloud compute go up, down, or stay the same? And let's time box this, and let's say over the last 5 years. Okay? So, by a show of hands, how many people think that the cost of cloud compute, now specifically just compute, right? You can also throw memory in there. But I'm not talking about like services and API gateways and stuff like that. Sorry. How many people think it's gone up over the last 5 years? Okay, reasonable guess. How How many people think it's gone down over the last 5 years? Nobody, one person. How many people think it stayed the same over the last 5 years? Nobody, okay. So the answer to this question is in this graph. Right now, I found this graph. There's a reference to it. We'll share the slides at some point. And you can see that if you look closely at this graph, right, again, this is approximately over the last 5 years. You can see it starts in 2019 and goes to about last year sometime. So let's say over the last 5 years. Now, there's this interesting inflection point right here, where it says the period during which AWS and Azure launched lower priced Graviton and Epic-based VMs. Okay? Now, you can see that there's a significant drop. I would say that this is probably somewhere between 7 and 10% drop in the cost of compute. And of course, this is compute. This is taken from, or these specifically is for US East, which is, as most of you would know, outside of DC, and it's specifically for AWS. But as you can see here, aside from this specific situation with Graviton and Epic-based VMs, prices basically stayed the same. The answer is actually stayed the same. Right? Now you might be thinking, if you are somebody who's been doing this for a while, you know that Moore's Law doesn't really apply anymore, but there is still efficiency in new generation chipsets and CPUs. You would expect this to continue to go down. But what's actually happened is that because the cost of everything has gone up over the last few years, electricity, manpower, right, people to staff your data center and all that kind of stuff, the cost has actually stayed flat instead of going down. If you were to look at this more historically, let's say we went back 10 years, you would see that the cost of compute has actually gone down over time. Okay? But because of various different things, increased cost essentially, it may be a little bit of profit taking, but I don't know the ins and outs of how AWS or Azure, or for that matter GCP, price their things and what their actual operational costs are and things like that. It stayed the same. Now, how many people are familiar with what Graviton and Epic-based CPUs are? Okay. So Graviton is basically ARM64 based CPU, and Epic are AMD-based x86 CPU architecture. Okay. Now, the reason why Graviton had such a big effect here is because Graviton doesn't have amazing single-core performance or single-threaded performance. What it is, it's very wide and it's more energy efficient. And of course the CPU is cost less, but the main part is that it's more energy efficient. So if you look at the pricing, and we'll get into this in a little bit in terms of exact amounts, you can take your Java application, and unless you're doing native calls, i.e. using J and I, your app will just work. Whether you're running a Spring Boot application, or you're using some other framework, or you're just running straight Java, we've had customers move from x86-based, i.e. Intel architectures to Graviton, and they see an immediate 20% improvement in cost. Now, the performance per core is a little bit slower, but what can you do in that case? You just add more cores, and you still save money. So this is an immediate win if you're looking for a way to go and impress your boss or your team and say, hey, I can bring down our $100,000 a month compute bill, EC2, Elastic build, whatever, just by switching to Graviton. Of course, you want to try it out first, make sure your app will run. But again, if you're not running JNI, then it's pretty easy to just go switch over to Graviton and just save a huge bunch of money right out of the gate. Okay? But we'll talk a little bit more about that in a few minutes. Okay. But when we think of the pricing factors, it's always not just compute. I'm going to focus on compute in this session, specifically compute and memory. I don't want to talk too much about storage and network and APIs and shared services and databases and stuff like that. If I start talking about that in terms of the overall picture for cloud cost and how to bring it down, we would be here for about 3 to 5 hours to talk about all this. And so we want to keep it short and sweet, focus on compute and memory. Right? But I do want to talk a little bit about architecture before we jump into some more of the specifics around the Java virtual machine. Right? So this is a diagram I came up with a while back. It basically talks about what are the different overall kind of large broad brush architecture, right? Everyone knows what a monolith is. In a monolith-based architecture, you basically are doing vertical scaling. Vertical scaling means that you get more compute whatever. You get more horsepower for your application by adding more CPU memory. It's extremely difficult to do because what you have to do is you have to physically get a machine that has more cores or a machine that has more memory. Of course, nowadays you can go and go to your cloud console if you're using VMware or whatever, select something that has more of both, but you have to bring your app down and then you have to bring it up with more of that, right? That's vertical scaling. And that is basically not elastic because it's not on-demand scaling up or down. And then of course, somewhere in the middle you have microservices. Microservices also have the capability of doing what's called horizontal scaling, and it is very elastic. So if you're running in Kubernetes, for example, you can say that I want to have a cluster of 10 nodes, and I'm going to run my app in it, and I'm going to scale that down or scale it up beyond 10 nodes if I need to, and you can do that very easily by a simple configuration, and sometimes even automatically if you're using auto-scaling, and of course, cloud functions or functions as a service are the ultimate in horizontal scaling because it automatically scales up and down for you. It handles a whole bunch of stuff. It's very elastic. So the reason for talking about this is because elastic style compute helps you get cost control, especially if you're using auto scaling. The system detects that you don't have as many operations coming in or as many requests coming into your application, so it will shrink from 10 to 7 or 5 or however many servers are actually needed to service that load and still have good user response time. So I'm still not a huge fan of Kubernetes because it's very complex and it requires a lot of overhead, in my opinion, to be able to manage properly a kube cluster, but you get the idea. So the other kinds of architectures around this, of course, is platform as a service. You may remember Heroku, you've used that in the past. And I kind of lump containers as a service, CAAS, and Kubernetes into the same bucket. I think of CAS as Kubernetes without any real management overhead. Like you basically go and give a CAS platform. If you're not familiar with the offerings from the cloud providers, this would be something like Amazon Fargate, AWS Fargate, Azure Containers, and Google Cloud Run. So you say, here's a Docker container, go run this stuff for me. And it will go and run this stuff, and it will scale up the number of simultaneous images of your Docker container, and it will go run that. And I don't want to spend any time on cloud functions because we don't have a lot of time to talk about that here. Now, I do want to take a quick aside here and point this out. So this person is a researcher at Google, and that's one of the important bits here at Google. And they came out with this fascinating study, and you can read the whole thing at some other point. Basically, they've said that our prototype implementation of using a modular monolith versus a microservice reduced application latency by up to 15x and reduced cost by up to 9x compared to using microservices. Right? So, how many people write or deploy microservices in here, out of curiosity? Okay, so a few people. Okay? Now, when we think about this, well, why do we move to microservices, right? And why are microservices so inefficient? You can probably guess what the answer here is. When you build a microservices, you're running small services, and there's a lot of communication that goes on between microservices, and you have to do JSON serialization and deserialization. That adds a huge amount of overhead and compute power required to do that. You also have to send stuff over the network. That adds latency and also adds overhead, like compute overhead, or network overhead for that example. But what I would suggest you do is go have a look at this, and it actually makes for really nice reading to understand, like, if you're building a system, what are the trade-offs that you're making when you go from a monolith to a microservice. I'm not saying you should stay on a monolith, but you probably have heard people talk about modular monoliths, and there's a great presentation from Spring I/O of May of this year, where someone from the Spring team talks about using Spring Framework to build modular monoliths. So you can read this paper, you have a look at what they mean in a deep dive session on modular monoliths, and why it can help reduce overall cost and, of course, latency. So let's dive into the Java part for a few minutes and talk about some JVM considerations. Right? Surprisingly, and I know it's not cool, well, everyone in this room thinks it's cool because they're Java developers, But if you talk to non-Java devs, they're like, oh yeah, Java's like, you know, it's kind of past history, it's not cool anymore, it requires too many letters to, you know, to build software. Anyways, Java is actually a great language for the cloud too. It's extremely power and cost efficient. It's very flexible. You can build almost any type of app for it. And again, the JVM has been around for almost 30 years. So it's 30 years of improvements to the Java virtual machine in terms of performance and lots of other things. It can be a language for all different types of application models. Now, one of the other things that makes the JVM really nice in terms of power efficiency is that we have something called a just-in-time compiler. If you're not familiar with what that is, it's basically there's a bit of software inside the JVM, and what it does is it looks at your code and it makes it more efficient as it gets executed. It does advanced things, for example, like in call site caching. A common one is method inlining. So whenever you call a method from another method, which calls another method, what happens is every time a method is called, you put something on the stack. And then when that method is run, you pop down the stack, right? But that adds overhead. So one of the low-level optimizations that can happen here is if the method is called over and over and the JIT sees that the same result is always returned from that method, it just takes that method and inlines it in that branch of code so that you don't have to hop on the stack and hop off the stack, right? So it saves a little bit, but when you execute something millions of times in a minute or 10 seconds or whatever, all these things add up, right? That's just one of the optimizations. There are hundreds of optimizations in the VM. One of the reasons why Java applications actually get more efficient over time because the JIT is continuously optimizing your code and making it better. Okay. Now, you do have a little bit of warm-up time that you have to accommodate for as the JIT kicks in and analyzes your code and makes it faster. Okay. So, in terms of power efficiency, this is, well, unfortunately I can't read it because of the font color, but you can pull this up. Some folks at a research lab wrote the same application across a bunch of different languages, and they opened up a server and attached multimeters to it to measure watt consumption and other things like that. But you can see they actually measured in joules. Of course, if you did double E, you know they can convert watts to joules. Joules basically means how much power you use it with. Okay? Now, again, this is the same application. They ran it for several hours and took measurements out of all these different programming platforms. And you can see Java is the most efficient. And for those of you who might be running C#, you can see it comes in at a close second. So yes, indeed, some empirical evidence in terms of how much, basically how much power a application uses using Java versus others, right? And the reason why this is important is because something that's power efficient essentially means that something is CPU efficient. Because what draws the most amount of power in a server or a computer? It's the CPU. Obviously, the memory also requires power, but it's the CPU that usually, like, you know, if you're playing a video game or doing some kind of video transformation, you'll hear your CPU spin up because, or sorry, the CPU fan spin up because it's drawing additional power. Okay? And just for givens, I put in some of the interpreted language, and you know, we were talking about how people love things like JavaScript and Perl and other things like that, Ruby, for example. But you can see that if you go back one, Java uses approximately, let's call that about 40 joules for this specific test, and something like JavaScript. This is hard to read, but I looked at this up on the table. This draws about 100 or something like that. So it's about 2.5 times less power efficient than Java. Okay? And again, I did not come up with this. You can go look at the link and you can have a read through this article. But again, the point about bringing this up is to talk about power efficiency and CPU utilization are go hand in hand. All right? So let's talk about some specific JVM optimizations, and let's look at some runtime JVM specifics here to give you an idea of how you need to think about how do I right size the number of CPU cores and other things that I have in my application. It's not a stop for some reason. What I'm going to do is I'm going to draw a quick diagram that shows, not a video, of this. that shows how the JVM starts up and what the CPU utilization is over the lifetime of a JVM app, or let's say at least the early lifetime. Okay? So I'm going to put two axes on here. Why does this not work? I did test all this before, so there we go. Okay, so on the bottom axis, I'm going to do time, and on the vertical axis, I'm going to do CPU utilization. Okay? So what happens when the JVM starts up? It loads all the classes. If you're using something like Spring Framework, it goes and constructs all the metadata that the Spring Framework uses, i.e. your Spring Beans, makes database connections, sets up objects for the thing to start running. So initially when you start up, you start using a lot of CPU because it's loading those classes, doing all that initialization of the framework, of your code, and all that kind of stuff. Right? So at some point, what happens is we hit something called app ready. Okay? That means that the app is ready to service the first request. So at this point, everything is loaded, first requests start coming in, we start taking requests, and our CPU utilization goes up, and then eventually the JIT starts kicking in, and we reach some level of JIT efficiency, where we start really going down in terms of CPU utilization, and then as the JIT optimizes more and more code, let's say we hit this point, we're at about 98%, and I kind of made this number up, but this is, let's just go with it, right? 98% code efficiency. So this delta right here is basically where the JIT is doing optimizations, okay? Now, when we size a server to run our application, what do we typically do, right? We're developers. So we will go and use the latest library, which is fresh out of the Git oven, and throw it into our application and say, let's go, let's use this new shiny thing. But when it comes to operational things, we're much, much, much more conservative, right? Because we don't want our pager or our phone or whatever blowing up on Saturday night or late on Monday or whatever. We just want this thing to run because we don't want to make ourselves and our team look bad. So what do? We over-provision the amount of compute and memory we have in our application to avoid the app crashing, basically, because of overutilization, right? So what we do in this case is we will say, okay, right, again, the vertical axis is CPU. So what we'll do is we'll add some extra threads or cores or whatever, and we will set our baseline to be like up here, right? So this is the amount of CPU allocated. I apologize for my terrible handwriting. That's the amount of CPU we allocate, but if you look at this application, you can see that we kind of peak like right about here, right? So we peak right about here in terms of how much CPU we're maxing out. But we want this headroom right here in case we get bursty traffic, right? Right, so we know that the JIT is optimizing our code and we're getting more efficient, i.e. we're using less CPU over time. So we actually have two problems here that we need to solve if we want to get the maximum amount of efficiency, i.e. have the lowest cost for running our actual application. So the first is the obvious part, which is this right here. Okay? How can we avoid over-provisioning too much? Because this is all waste, right? We're basically wasting our money here because we've over-provisioned the number of cores, threads, virtual cores that we've assigned to it. Now, in all fairness, AWS, at least I know, has a feature that you can enable which says, I want dynamic core, I want a dynamic number of cores for this EC2 instance for this amount of time. So you can actually go into the AWS console and say, for the first 10 minutes, allocate an extra 2 cores. So I know I have this curve where I'm going to be using more compute power as the app gets set up and as the JIT kicks in and has not yet fully optimized my code. Okay? So you can do that, and that is helpful. But wouldn't it be nice if we didn't have to worry about that kind of low-level stuff? Okay? Now, the other part that's wasted is this part right here. Right? This is basically our JIT warm-up time. You remember I had this on a slide earlier. Warm up. Again, I apologize for my terrible handwriting, but you get the idea. JIT warm-up time. But this is also wasted CPU cycle. Now, with the AWS dynamic core modeling, You can avoid that by just assigning a few cores, and you can get over that hump. But what about the over-provision part, right? That's what we're trying to solve here. Because this is over the lifetime of the application that we're worried about that, right? We basically want our baseline to be somewhere around this neighborhood, right? Yes, you'll see ups and downs, so you will need to over-provision a little bit to capture when you get heavy traffic. Because as you know, every application doesn't have traffic that's just flat like this in 24 hours of the day. Like if you're building something in the fintech world, when the markets open up at 9:30 in the morning, you get a surge of traffic and then kind of levels off. And at lunch it goes down, it might come back up, whatever, right? It's kind of up and down. Think of whatever your application is, right? If you're doing like, if you work for a retailer, and you're doing like a sale, you get a lot of traffic at certain parts of during the day or certain parts of the week where you have people trying to buy stuff off your website. Right? If your application, and usually traffic is up and down like that. Okay? So, there's a couple of things here that we can do to alleviate the over-provision. First thing is to bring that ceiling of over-provision down a little bit and basically take a little bit more risk. Say, all right, I'm going to bring that down, not have as big of a safety net, and I'll save some money. The other way is to just have a more efficient JVM. And this is one of the things that Azure Prime is good at, is we have a much more aggressive JIT compiler, so it can actually bring the threshold for how much basically CPU it uses down, because our JIT, which is called Falcon, it is a proprietary JIT, it will optimize your code more aggressively so that your app will actually run more efficient over time. And on top of that, Azure Prime, our high-performance VM, also has hundreds of optimizations that make things faster compared to OpenJDK. And of course, we also have our own garbage collector, which is a continuous garbage collector, which helps also with high-performance JVMs to have a high-performance JVM. So I know I'm just a bit over time, so I'll start wrapping this up with some quick additional tips here. We've talked a little bit about this. I don't want to go into GC pauses right now because that's actually a much longer discussion about what you can do for garbage collection. That's an entire presentation itself. Right. So one thing that you might be considering is, well, if your JIT takes a long time to warm up, does that mean short-lived processes? For example, if you're running in a cloud function or running in a microservice in Kubernetes, or maybe your app is only up, or sorry, an instance, specific instance of your app is only up for 10 minutes or 20 minutes, and the JIT takes a while to warm up, right? So let me ask you a question for the Java Devs engineer. Say you have a medium-sized Spring Boot application, 20,000 lines of code, okay? And you exercise this application across most of the code paths, i.e. you put under heavy load. So for an application of that size, how long do you think the OpenJDK JIT, the just-in-time optimizer, takes to reach, let's say, 90% efficiency? Anyone want to take a guess? How long do you think it would take? For a standard Spring Boot application, like let's say it's a RESTful or serving, in JSON endpoints or something, or maybe even websites. How long do you think it takes for that thing to reach peak efficiency, near peak efficiency, 90%? You want to guess in the back there with the hat? No. Andre, you want to take a guess? 50 seconds for a 20,000 line Spring Boot application. That's a guess. Anybody else? It's not a bad guess. We're getting closer. So, for an application like that, it typically will take 10 to 20 minutes for it to reach peak efficiency. Again, about 80–90%. The other assumption is that we're putting it under moderate to heavy load, so the JIT can look at all the code paths and stuff like that. And the JIT does take a little bit of time to get warmed up. And again, we made a lot of assumptions there. Standard modern Spring Boot application, running on a modern VM, and under moderate to heavy load. Okay, so it does take time to reach that level. Of course, we reach a lot of things which are quote-unquote low-hanging fruit in terms of the JIT compiler will get optimized much faster. So the curve doesn't look like flat down like this. The curve looks like this, and then tails off as I drew previously. You have that long tail where it gets harder and harder for the JIT to actually optimize code because it's optimized all the things which are easy Now it's looking at more advanced things to do to optimize. Anyways, one way to alleviate this is that JIT optimization warm-up time, right? If you go back to this chart, wouldn't it be nice if instead of having the curve, well, we have, sorry, instead of having a curve that goes up like this, wouldn't it be nice if the curve just looked kind of like this, right? That would be great, because now we don't have to worry about this extra waste here, which will always be there, because that's how much we provision the application for. So Azul also has another proprietary product called Ready Now, which will be able to provide a JVM, a warmed up JIT that you go and warm up in like staging or somewhere in the test environment. Or we also have a very advanced product called Cloud Data Compiler, which is a server that sits in the background and it can push JIT optimizations to 10 or 100 servers running that specific application over the network. So you have one server using CPU to optimize the code and push stuff through all the instances of it to get this flat curve, more flat curve that I just showed. All right. So we talked about these things already. Talked about right now Cloud Data Compiler. I don't want to get into garbage collection because that's a bit of a longer discussion, like an hour or longer. It gets more efficient over time, which we already configured. Okay. And I've already talked about this stuff right now in CNC. So let me just close out very quickly on stuff that you can do. We talked about not over-provisioning as much to save cloud costs. Right, so just make the extra headroom you have less. One of the actual biggest factors in cloud cost waste is actually quite simple. It's the second bullet on here. It's essentially VMs that you're running that you're not using. So you're working on something. Okay, I'm going to try this out. Go and run it. Spin some stuff up on AWS or in a data center or whatever. And you're like, oh, it's noon, it's lunchtime. I'm going to go get lunch. And you just leave it running. Or you just go home for the night. You're like, oh, I'll pick this up tomorrow, right? It's actually something really simple that can actually adds up over time. And then kind of similar to that is the lack of automation around cloud costs, right? You're able to automate more stuff and be able to like bring servers up and down when you need them, instead of just leaving them up running all the time or just more longer than you need to. Get automation around that can also significantly reduce cloud costs. Now, these are kind of more non-technical things here, but a lack of governance, right? You don't have a team within your large organization which sets rules for how you're supposed to use cloud services and what you shouldn't use and what are like some guidelines or even rules around what you're allowed to spin up and things like that. Lack of governance leads to cloud costs, and of course lack of guardrails, right? You throw something out, something spins out of control, and now all of a sudden you have like a $10,000 a day bill because someone left their performance test running on production for like a week instead of shutting it down, right? So having guardrails around that where you don't just keep scaling up and up and up automatically and the cloud cost goes through the roof. The last one you're probably familiar with a little bit, which is unexpected egress and ingress charges. This basically means data transfers into and out of your cloud platform are not cheap, sometimes not even cheap within the same cloud provider between regions. So there are some ways to ameliorate that, but not really a lot. So, okay, we talked about this stuff already, dealing with non-uniform load. Nobody has load that's consistent. I like CAS over Kubernetes for simplicity, because you can get that auto scaling. You say, here's a Docker container with my application. Just go run it. And it goes and runs it. Of course, as you know, nothing in life is free. Running a CAS solution like AWS Fargate, Azure Containers, or Google Cloud Run is more expensive than just spinning up your own VM, EC2 or whatever, right? So they add a little bit of cost to it, but you have to figure out for yourself if it's worth running the CAS versus managing your own cube cluster, or how are you planning to deploy it, okay? So, all right, we haven't talked much about cloud functions, but cloud functions are the ultimate elasticity, is they aggressively scale up and scale down. You don't have to do anything, it just does it for you. But it does require a new way of architecting your applications. This cloud function generally should be very, very small. And to give you an idea of what very, very small means, it should be no more than 100 or 200 lines of code total. Again, 100 to 200 lines of code in a single cloud function. You might be asking, well, if that's the case, how do I write an application? Well, cloud functions are meant to be small units that do one thing, so you write loads of different cloud functions and you weave them together to build a full application. Okay? But that's an entirely different topic. Again, I have a great presentation on serverless for Java where I talk about this if you're interested in seeing that for your team or for your company. And I mentioned Graviton earlier, so I want to close on this. A couple of key stats here. Graviton is typically 50% more, less expensive than x86 for compute. Right? The trade-off here is that Graviton doesn't have great single core, single vCore performance. But again, it's all about scaling horizontally, wide, as opposed to scaling vertically. Right? So add more cores and still save money. And Azul also has a build for ARM64 for a high-performance JVM. So if you go to Graviton, boom, you're saving 30, 40, 50% right off the gate. And if you use Prime with it, you can actually save an extra 25% in compute power, because again, a high-performance VM is 26% faster than OpenJDK on Graviton, and that's because all the low-level ARM64 improvements we've made in our code. Okay? All right, so one last thing I want to talk about very quickly is some of you may be running or looking at managed services instead of doing DIY. Now, what do I mean by this? Okay, say that I want to run Cassandra or I want to run Kafka. Kafka's still hot, right? Anyone building stuff with Kafka today? No? Okay. You're familiar with what Kafka is, right? Some folks in the back there. So you might say, okay, I'm just going to go to AWS or GCP or whatever, and I don't want to manage a Kafka cluster. So I want to use their managed Kafka service. Okay? Now, starting on managed services, in my opinion, is always a great idea, because as you're building an application, a new application especially, or you're adding Kafka to an existing application, I'm just using Kafka as an example, this could be any managed service. It's great to be able to just focus on building the application rather than worrying about all this infrastructure stuff. Like if you have deadlines and deliverables and stuff like that. So starting off with managed services when you're not using a lot of it is actually a great idea. But at some point what happens is, if you were to draw this in a chart, you look at cost and you look at your utilization, at some point the charts diverge like this, where your cost is not matching the amount that you're using previously because you're using much less of it. So the question in terms of cloud cost is, can I save money by using a managed Kafka, again, or a managed service of some kind, versus is it cheaper for me to manage my own Kafka cluster? Okay? And the answer to that question is that you have to kind of model out when I hit 1 million Kafka messages an hour, when I hit 10 million an hour, where's that line for me? Because obviously, when you manage your own Kafka cluster, now you need to have a Kafka specialist or two within your team or your company. How much does it cost to employ that person versus how much am I paying AWS to have managed Kafka, right? So again, you have to draw a graph, and where that inflection point is, where it costs more to use managed Kafka versus the flat line of including personnel costs for managing your own Kafka, right? Basically, when is doing it yourself worth the money and the time? All right, so with that, I know I'm over time, so I will shut up now. I'll take a couple of questions since we still have a break. But if you wish to see the more extended version of this presentation or one of several other ones I have on cloud architecture and Java, please hit me up. My email address is pretty easy. It's just ppatel@azure.com, or you can find me on Twitterverse, the Twitterverse at Pierre Patel, and on Blue Sky, and on LinkedIn as Pierre Patel. Thank you for coming. I hope you enjoyed that, and I apologize for going over time, but we'll take a few questions in the break now.
All right, thank you, Pratik. So as we mentioned, there is a break, so if you do have to go get outside, see some sunshine, or use the restroom real quick, please feel free to do that. We're not holding you hostage here. But Pratik is going to stay up here. If there are any questions, he'd love to be able to answer them. So,
Yes.
got a question. Was that you saying it?
Yeah, that was my mic. It just like all of a sudden turned back on. Yes.
Ah, hi.
You had a question, sir? Yeah.
Yeah, I was curious with respect to the just-in-time compiler. Are there certain code patterns that you can employ to make it more efficient?
Okay, so the question is if I were to use certain styles of coding or certain ways of coding, can I make the JIT run faster or optimize my code better? It's a great question. The short answer to that is that it doesn't really matter because the JIT has been around for so long and there's been so many different types of optimizations put in that if you just write kind of standard, what we would call standard code as a Java developer, he will just do his job and do it well. Okay? But saying that, if you do certain things which you would consider to be not good ways of coding, then yes, there are things you can do. So for example, using, a lot of people like use thread locals to store memory or to store stuff, right? Thread locals are great for certain use cases, but because it's hanging on to that extra memory, this doesn't necessarily affect the JIT compiler, but it does affect the garbage as well, right? So now you have this shared memory state which may be held by multiple threads, so the garbage collector basically can't go clean that up, so now you're using more memory. Right. And the garbage collector has to work a little harder because it has to make sure that's not getting clean. From another point of view, from like more strictly JIT code point of view, when we write stuff, we want to generally, have write object-oriented programming, right? And you favor more object-oriented programming versus composition, but kind of reducing, method inlining is done for you anyways by JIT. But if you have object trees which are very deep, that can also affect JIT performance. But it can also mean that you still write with a deep object tree and you rely on the memory management and other techniques like call-side caching within the JIT to optimize that over time. But it does make it more complex for the JIT to optimize it. So the straightforward answer is the more simple your code is, the better the JIT is at optimizing it. The more complex you make your code, right, in terms of the structural complexity across classes, methods, having data objects. This is one of the reasons I love records, because records are slim objects and have lower overhead compared to the standard objects, right? Records are basically just data holder objects instead of objects that have data and behavior. So, anyways, that's probably the best answer I can give you off the top of my head. Yeah, just these two experts over here, they could probably give you a better answer than this.
Okay.
Yeah.
Thank you.
And so, this one, not that one. I'm just kidding. Any other questions? Thank you all for coming. Thanks for the question, Mark. Oh, sure.
Hello.
What do I?
No.
gonna do, talk to you next week. Want a piece of that? I would prefer. Not big one.
Okay. So.
I like that, but I think the white more readable. What do you think? The white more readable. But the focus is the white, the white. Yeah, it's more readable. Yeah. More readable.
All right. Is everybody back? Have a good break. Get all your questions answered. Meet some new friends. Woo! We're lively today. All right. So for those of you who are here, again, I'm going to ask if you can just come to the front of the room. I promise it's nice and warm. We're friendly up here. But we're in for a treat. So continuing on our Java theme, we are very lucky today to have not one, but two Java champions with us who have traveled from New York City. So before I let them take it away, just want to say thank you to Chandra and Rodrigo to be coming here. I'm super excited for this talk. Void main, it sounds a little suspicious, but I'm a little intrigued. So without any further ado, let's give it a round of applause for Rodrigo and Chandra.
Right. Hello, everybody. Can everybody hear me fine? That's the first question I have. Show of hands, who cannot hear me? Who can hear us? All good? Can everybody read what's written on the screen out there? All the way sitting back there. Everyone good? Readable? Awesome. Hi, my name is Chandra. I'm one of the Java champions, and my fellow speaker here is
Rodrigo Graciano, nice to see you. Glad to be here. Thank you very much for the opportunity to be here.
Thank you. So very quickly, what we're going to do is we're going to talk about changes in modern Java with respect to taking a project that was written in Java 8 and converting it into a Java 22 or 23 version of the same product. Now, we would not have the time to do this live today. Usually what we do is hands-on, we go and change code and show you as we change code what the features look like. What we're going to do today is compare and contrast how a feature that's working in Java 8 compares to what it looks like in Java 23, what efficiencies it brings you. And for the sake of what we're going to share, this project is actually available on GitHub. You can check it out later on, and you can run this yourself as well. So there are instructions on how to do this. There's a how to set up guide that will help you get set up on what you need to run. Everything's present there, right? So we'll share this document as well. And the conference itself is set up such that you have a conference that we created. This is our project. And in this conference, you have different kinds of individuals who participate. There are attendees, there are speakers, there are staff and vendors and sponsors who have booths. Attendees pay money and get a badge. Speakers get a t-shirt and also get a badge. Staff gets hats and a badge. And of course, vendors and sponsors get a booth, which is what we represent down below. and speakers are associated to a session. So that's our simple setup that we'll be using. Attendees can also have alumnus attendees, which means they've attended in the past, which means they can get some discounts. And in the future, we're thinking about enhancing this project to add more, I guess, diverse kinds of staff, such as admin, security, front desk, etc. That's the premise of our application. This is coded in Java 8. As you can see from here, this is the Java 8 application, and it's equivalent Java 23 application is below that.
Right? DevIgnition?
Yeah. Oh, and by the way, for anyone asking us questions, we have a little surprise. We'll be handing out chocolates for good questions.
Right. Right. We welcome questions. We want this to make it interactive. Questions, comments, is good. There's a catch. Always a catch.
It's a catch.
When you ask a question, you need to ask me or Chandler. Ask me, you get one chocolate. Ask Chandler, get two. All right?
Something's not
Only
right.
fair. Only fair. All right. Want to get started?
Yes, please do. Meantime, I guess I'll try to open this without making a lot of noise. Okay. So here's the agenda. And go ahead, Rodrigo.
All right. So those are the topics that we're going to be presenting today. Which version of Java are you using? 17?
17.
11. Good. 17.
Anyone still in Java 8 first? 8 to 21, okay.
All right, good, good. All right, so those are a few features that we think that's important. And we gave this talk like 2 months ago in Denver, and we have like an hour and a half. So we're trying to explain as much as possible in 30 minutes. We're gonna cover what affects the developer, let's say when you're coding, what affects you the most, and features that you can be using. So text blocks with expressions, records, steel types, we're gonna be presenting today. And this is running on Java 23 early edition, so the most recent feature. And we can start with text blocks.
Okay.
So text blocks I think was part of Java 14 or 15, if my
14, yeah.
14, all right. And it came to solve a, let's say, a problem, right? We were writing codes. I remember when I was writing like those big SQL queries, and then you have like slashes and you add and codes everywhere, and this code here is not very readable. This is only a few lines of code, but I remember having SQL queries that was like, I don't know, 30, 40 lines of code, and then you're gonna read that, it's hard to read. And text blocks came to be a better way to make the code more readable. And if you look on the right side, that's the same code as the left side, but using text blocks. Right? So text blocks is basically a string. Is a string behind the scenes is just a string. Different from the string, you have the 3 quotes to open and the 3 quotes to close. Much more readable. See, you don't see anything more. You don't see the double quotes everywhere, the slash, the line breaks, and everything. And different from strings, it will keep the indentation, right? And the key here is where the quotes end, right? So when we finish the code, the 3 quotes, that is going to then based on that. So everything you do, like if you print it like a regular string, you're going to miss everything, right? But on the text blocks, you keep indentation, you're going to keep the line breaks and everything. Watch where the 3 quotes ends, that's where it's going to end from. The code on the right is exactly the same code as the left, but using text blocks.
And this is the second example. You want to speak to this as well?
The thing is very similar here, but you can notice where the indentation is right now. Yeah. So the code will be like 1, 2 tabs to the right. If you print that string, you're gonna print exactly like you see here with indentation like 1, 2 tabs to the end. So,
Rodrigo, what happens if I were to do this? That I put my starting triple quote all the way somewhere else, maybe further down.
perfect. Doesn't matter where you put steps. What matters is where you end. So it's gonna base your indentation base where you close the triple quotes.
Right? So the modern text block syntax only relies upon the ending of the triple quote. The beginning of the triple quote is meaningless. You put it anywhere. You put it on the same line that you start, you put it anywhere. It is this quote starting position that determines the origin point, and your text will be indented by that much what you see here, this will be your indentation for. So it's much more readable. You don't have any kinds of escape characters. For example, here, when you had to put a here, and if I had to do some sort of a double quote around it, I would have to escape. With my text block, I don't need to do that. No need for escape. It's pretty amazing.
So there's no change in performance using text blocks. It's only to make the code more readable.
All right, and reminder, we got chocolates. Questions being chocolates.
Any hands raised? Who wants candy? Alright.
All right, moving on to switch expressions.
You want to talk about switch expressions while I bring that up?
We have a bunch of different things that's changed for switch expressions. And if you look, we're looking at the fixed to line 163 on the right. Right? Let's start with the left. Right? So we have here a very common switch expression that we're using. And I probably a few times in my life, I wrote a switch expression and I forgot to put the break. Right? And if you're not a developer, I'm sure that happened to you as well. I forgot to put the break, and what happened when you forget to put the break? It's gonna return.
It will fall through. Fall through.
Perfect. That's not the behavior we want. And
May I?
sure.
And he asked you, so only one can.
Oh yeah.
Yep. Should have asked me.
All right. So you can see we're doing switch expression. We are switching on that in the get payments, and then we're doing case and max. Then we're writing all the business rules, and then the break, and then the break, and then the break. Moving to the right side, we have the same thing using switch expressions, right? Before and after. It's much more readable. It's the same code, but now we are already returning, right? We don't need to set in the middle, right? The value of the processing fee. We're just returning it based on the result of the switch expression. Notice that now we have the arrow. We're using the arrow, so that's how you say that's the value right now. So K is MX, then the arrow. 0.1. No need for breaks anymore, right? So is the code more readable now? Yeah, right?
Makes the code readable and stateful. No need for a break statement. And this is called the yield syntax. The arrow syntax is called the yield syntax. And what it does is allows me to capture either a computed expression or a constant, as we did in this case. Now, if you have a computed expression, you obviously can also use something more complex than this. For example, if I had to instead calculate something instead of putting in a hard-coded value, I could do something like this, right?
I was hoping that would become a question.
For you. This is the other way you can write the same code. So either you use an arrow syntax if it's a simple return statement, or you actually can have a more complex block, but at the end of the complex block, you yield the result. Yield serves the purpose of returning a value as well as functioning as a break. So it does both. Any questions on this? Everyone understand how this works? Yep. All right, so may I take over? So I'm a big fan of algebraic data types in Java. That's something I speak a lot about. And one of the things that I wanted to share is the pattern match techniques that Java is in. And this goes very well hand in hand with switch expressions, and that's what I was sharing. So I'm going to go back to doing a diff again on these two, and then showing you some. Okay. Now, focus only on the left side of the screen. Don't look at the right side yet. Notice the amount of text that I have to put up here in order to determine if the person who's winning a raffle, there was actually a raffle winner, part of my conference where we were handing out some raffle prizes. But only if you're either an attendee, speaker, or vendor sponsor, you can participate. Staff does not participate. That's our rule, right? So what we're doing here is we're checking for some random people who we picked from our attendees, and check if they are either an attendee, we do something with them. If they're a speaker, we do something else with them. If they're a vendor sponsor, we do something else. And if they're not allowed, you actually throw an error, right? So it throws an illegal state exception, which is a runtime exception. So it doesn't handle the flow of your general code. Now this is a lot of logic for something as simple as that. With the switch expressions instead, we just focus here, you'll notice that I simply have a switch on an allowed person, right? And this allowed person, in case they are an attendee, so I'm actually type checking for what this individual is. And if they're an attendee, I can use an yield syntax and do something with it. I can do the same with the speaker and the vendor sponsor. Now this is not all I can do. I can do a lot more. What I could do is put some guardrails around my conditional checks as well. If they're an attendee and they are about 50 years old, I can do something different. And if they're under 50, I can do something else. Right? That capability exists with the switch pattern match instance of now in Java. Any questions about what we just shared? And of course, I could also do a default and throw an exception. So the catch-all would be to throw an exception, and this is a very exhaustive scenario. Switch cases help me exhaust my scenario better with the default, and then show you another example where you don't even need a default. Any questions about this?
Does this replace like method overloading, for instance?
Not so much it replaces an if then else, it replaces a switch with conditional logic built into it. But more importantly, what you're doing is you are type checking, you're pattern matching on the variable that you switch on. So that's where its power comes from. Could you have done this in older Java? You do it very similar with the instance of. That's what it is. Yes, please.
So why would you do this instead of putting a polymorphic behavior on the second?
Why would you do this instead of putting up more or behavior? Sorry? Polymorphic behavior. Yes. So that's a great question. Can I do that? Yes. Can I put polymorphic behavior on this classes? Yes. This is an instance where you don't know what you're getting back. You know that you're getting a base class back, but you don't know exactly what the type is, and you have to make a deterministic approach to the type on the fly, is when this is used. So both are equally good. This one is better for readability, and it is also better when you have ambiguity. Great questions.
Does this work with enums too?
Yes, excellent question. So, sorry, he's gonna get 2 more candies. You can give that to other friends, you know. But the question is does switch case work with enums too? And yes, it does. And not only does it work well with enums, it is amazing with enums. If you specify an enum that has 3 values, let's just do it, right? 3 items in your enum, and you put those 3 in your switch case, you don't need a default. It's exhaustive, right? And if you don't put all 3, it is actually going to throw an error. The Java compiler will throw an error saying your switch case is not exhaustive enough. So I'm gonna, don't know if we have time, but yeah, may I take a quick minute? Sure. Because that's an excellent question. So we are back here, right? So let me get rid of all this stuff. We don't need all this stuff now. Okay, so here, right? Let's assume I take one of these out. You notice that immediately something will end up there? And if I were to go read that, it tells you the switch expression does not cover all possible cases. Right? So it works with enums and it does a better job with enums. You can go on in there. Great question. Awesome. How about nulls? Great. That's another excellent question. Sorry. These are amazing questions. Null is a special case, and you actually can do a switch expression on a null. Null can be specified as a type, and if you have a null type, you can actually do something with it. You can conditionally perform a different execution through an error with nulls. And you treat null as a special type. Yes. So, if time permits, end of the session, we can sit down and I can actually show you a demo of that. If I start doing demos, I'm going to get this number. I don't want to do that. Okay, so that was the pattern match instance of. The next thing I want to show you, and I just want you to be aware that my IDE shows this as an error. If it does work, I promise to assure you, but it's going to show a little red squiggly line when I show this to you, so don't be scared. So let me just go to it, right? Are we good? Rush, run. Okay, so this is the syntax. Once again, I'm just going to make you focus on the left side first. What do I have here? I have a discount variable that I'm randomizing, and if the discount that the random value returned is of a certain value, that is less than something, I'm doing some sort of a printout. If it's between some other ranges, I'm doing something else, etc. So it's a very simple logic where, based upon the value of the random discount that I'm getting, I print out a message. This reads fine, but what am I doing here? I'm first creating a random value and then checking for some conditions around it. And the more modern syntax that you find in Java, if I could move this, is now I've created this count and I'm switching on it. Biggest catch being the switch is on a primitive data type. I'm switching on a primitive data type, and I have some conditional logic in here where if the value is a double instance of check on a primitive data type, which used to never happen, and when D is of a certain value, I can perform an action. This is the guardrail I was talking to you earlier about, and I can do something very similar, use the exact same variable name. I've not even changed the variable name, it'll have a different value in this case. This is what is called flow scoping, and this is with the more modern switch case syntax in Java, where I have two different cases with the exact same variable name, and their values are mapped to whatever the condition is. That's pretty cool. And I have my default, of course. Any questions about this? Everyone understand this logic? And this was the squiggly I was talking about. It's only failing on my IDE right now. We just discovered it this morning. But it works. I can actually run this.
More readable and primitives again. And then you have the when. The when is very, very new though. Probably 23, 22 or 23.
Right. So these are guardrails. And guardrails are amazing because not only can I do a type check, which I do in both these cases, and I'm doing a type check on a primitive data type, I can guardrail protect it with some values as well. There's a boolean condition. I can have multiple conditions in there. Very powerful. Rodrigo is rushing me here. I don't know if you heard this. All right. The next one I'm going to talk about is field types. How many of you are already familiar with field types? Very few folks, so good. I don't know if you remember the picture that I was sharing earlier. We have this attendee, speaker, staff, vendor, sponsor, and alumnus. There's different kinds, I guess, people who are attending our conference. Just want to very quickly show you the difference between how old Java versus new Java does things. Okay, so I'm going to focus on the left side real quick, show you what it is. I have this class called allowed person that you can see here, and it's a public class. The problem with Java is when you have a public class, you can extend it to any number of subclasses. There is no control. And if you want to control, what you had to do in the past was make it final. And no one could extend that class anymore. There was nothing in between. There was no way I could limit the number of extensions possible from a given class. And that's how Java used to work before. So here's an example of C class. I have an attendee, it's an allowed person. This is good. I have a speaker, allowed person. This is good. I have staff, an allowed person, which is good. I have vendor sponsor, is good. But I also have an invalid attendee that extends allowed person. This was not possible. There was no way you could prevent this from happening in the past. There was no control. With the more modern versions of Java, Java 14 or 15, we have what's called a seal type. The seal type basically allows you to limit the number of extensions the class or interface can have. Here we are using a seal class. You can also have a seal interface. And the seal class permits attendee, speaker, staff, and vendor sponsor. Guess what happens to the invalid attendee? They're no longer permitted because that's not allowed anymore. Certain rules for the seal classes. Your seal class extensions can either be a seal class themselves, because we'll have further, I guess, extensions. They can be a final class, which means they can have no extensions. You see that in our case, alumnus and speaker are final. You can have a non-sealed class, it means it goes back to a public class and is open for further extensions, because we said in the future we want our staff to be of different kinds, we were trying to classify them into types. We don't know what they are, so it's a future project, so we non-seal it. Or we make it final, right? So there are the different combinations that allow these two types. Any questions about this?
So a non-sealed class is extending the sealed one, so then would anybody, like through the jobs, would anybody able to extend the lab class?
So as long as you're extending from the non-sealed class, you're good. You can extend beyond the non-sealed class, similar to how you would extend from a public class. Nothing is stopping you. It's almost like republic classing it is what happens when you do a non-sealed. For example, in this case, when you have the non-sealed class stack, you are unlimiting or delimit, you're removing the limits on who can extend. Now, what you made this is a public class and everyone can extend this class. You can further seal it later on, but right now it's fully extensible. Anyone can extend.
So it's like so a non-sealed class, so you can seal, I'm assuming the sealed is class is sealed for some reason.
Correct.
So then if it gets out like not the next something.
So in this example, are you asking if I could extend to another class?
Yeah, like, so allowing is sealed, right?
Yes.
And then somebody extends that, like let's say random sponsor extends that.
Right.
Then you make it unsealed.
Yep.
Then would the other person's methods be all successful? If anybody who extends random sponsor?
They would. So it's a simple extension, so nothing changes in Java.
You have the ability to open.
Correct. You're just opening the extension capability. The methods are always available. Super methods are always available. Great question. You've already got Candy. If you want to give it out to your friends. Rodrigo, you want to?
Yeah. All right, let's talk about records. So records is one of the nicest feature of Java. Every developer likes records. And if you're using Lombok before because you didn't want to write your getters and setters and everything, don't anymore. Use records, right? You're a modern Java developer and use records. So records, if you look at here on the left, you see that for any data class we were creating, you were writing, declaring your variables, and then your constructor, and then you have get and make setters, and then string and hash code, and all of that for nothing. There's no business value added here, right? And then people started using Lombok because they didn't want to write all this code, even though your IDE can generate all this code. But records became to solve all that, and the code in the left is exactly the same as the code in the right. That's how you write Java records. So you don't need to write anything. So behind the scenes, that will create a final class. You don't have that because the records are final, not final.
Effectively final.
Right, because you cannot change a record, but if there is a collection, you could basically change that's behind the scenes. But record is, let's say, almost final. There is no setters in a record.
You cannot reassign the attributes of a record to different values. For example, if I were to have, in this very example, I have session title and session abstract. They're immutable, they're strings. They're fine. Speaker, you could change the values of the underlying speaker. You just can reassign to a new speaker. So it's effectively final. The containers are final. The contents of the container can change. So just be aware of that, right? If you really want an immutability, you will make speaker also immutable. That's one catch that you should be aware of.
Perfect. So again, behind the scene, that's going to generate a string, equals, a hash code, and your getters. Catch. The getters are not going to be get session title. They're going to be only session title. There's no get anymore, right? And that's generated for you behind the scenes. So easier, one line of code to do what 30 lines of code you should do before. Much easier to read, right? You're going to associate the record, then on the constructor, you're going to pass all the values. much more readable, easier to do it. You don't need to use one block anymore. Right? You're free from it. Questions?
I don't like Lumbo, as you can tell. Right. The next one we want to talk about is vector patterns. As I told you, patterns are something I'm very passionate about. So we're going to go back to patterns. But in the interest of time, we're going to do this real quick. And anyone having questions about the patterns, please do catch up with us later on. We're both very interested in talking about vectors and patterns.
Yep.
So, where is it? Here. So this is probably one takeaway I want all of you to focus on. Here, I have a session, and based upon the session, I am pulling out the title of the session, and I'm getting the speaker from the session's main speaker. So I'm doing a few things in order to get to the title and the speaker. This is old project, and we don't do anything like this anymore, because all I want to do is bring the speaker person and master. What I can do instead is I can create an object, check its instance of a session, and further break it down to title, underscore, I'll get to this in a minute, and speaker. So, without me having to extract these variables from my record, I was able to extrapolate them directly from the record object, break down the record, and get to the value directly. All this in my if statement is the record pattern. Now, for the underscore itself, I don't care about the section name or the abstract, and I can just underscore it, which means I'm ignoring the style and complete. Much more readable. Someone who's reading this one line knows that I'm focused on the title and the speaker, and I don't have anything to do with the session abstract, right? Which is super awesome. And then, right there, I'm able to get to the speaker, first name and last name, directly without me having to extract those values within the session, getting that data, and then use it. So that's super cool. If you have any questions about this, please look at those after the session.
1 minute left, that's good. Right, and the last thing that we want to talk about today, or no, it's not the last thing, so let me look.
We have 1 minute.
Your basic hello world in Java, right?
I'm not even going to do a.
If you look at our basic, look at public static, void main, you declare your class, you have imports. Java is trying to be more friendly for whoever is starting with Java, first starting with Java. So instead of having to declare class, a public static, void main, string args, and everything, you can remove everything and just put void main. Right? If you have a one single class, you don't even need to declare the class name. It's going to create an anonymous class in the background. You can just start void main and print. Right? Removing the public, removing the static, removing the class declaration, everything to make it easier for you to start with Java. You have 10 seconds.
I have 10 seconds, okay. That's good enough. So coming back here, I'm just going to go through the new code. I'm not going to spend time on the old code. So just wanted to show this real quick is, for instance, in LMS, where's my LMS? I had it somewhere. I know I had it somewhere. Here. Okay. I have my identity, and in my identity, before my super, I'm able to write some conditional logic, which was not, this was not declared as a part of Java in the past. Super had to be the first construct, and the compiler would fail you, although there was nothing wrong with the code. So right now, it is possible for me to put some logic ahead of the super in Java. And these statements should not be using anything about this object. They can be very generic. They can use static calls, but they cannot use anything within the object itself. But conditional logic and exception handling, validation can happen before the super. So I guess, yeah, we're out of time, and there's a lot. Probably kill me if I don't finish up now. But thank you all. If you have any questions.
Thank you.
All right, thank you, Rodrigo and Chandra. So, make sure you stick around. They're going to be here still for a bit longer. So if you do have questions, write them down. But next up, we also have another live coding session that I don't think you guys are going to want to miss. So next up, we have Lawrence Lockhart, and I'm going to make sure I read this correctly because I don't want to get the title of the presentation wrong. But I believe you're coming to us from Memphis. Oh, hot diggity dog. We're in luck today. So, oh man, I should make my request next time for barbecue, huh? But today Lawrence is going to be bringing us full stack from the back, a Java-driven approach to building web applications. So, looking forward to this. Let's just give him a moment before we give him that round of applause welcome.
Yea or nay? Yea or nay? Good? Not yet. Yes, I know it's for
All right, let's give Lawrence a warm welcome.
All right, let's get started. Good afternoon, or good morning, rather. I'm Lawrence Lockhart, very happy for the invitation here from Greg Herder. Someone else who actually was slotted for this position, and they could not make it. So from the bat signal, I flew in on the Batmobile that's otherwise known as the airline. So very glad to be here. You know my name. I'm a DevRel at Baden, and this very long, obnoxious title, full stack from the back, building for the web with Java. That's what we're talking about today, but what the heck does all that mean? So let's start here. A couple of people you may or may not know. So the guy in the dark colored shirt there, he's Marcus Hellberg, Vice President of Developer Advocacy at Baden. Also my boss, so you have to know him, but good job. And by the way, this will be a very interactive session, even though there's a whopping dozen of us or so. So when I say different questions and things, feel free just to shout out answers if you like your shirt. So the guy in the white shirt, anybody know him? Give your name? Josh Long, thank you, good. Spring Developer Advocate, Baden Champion, Java Champion, all around pretty decent guy. This picture is taken from the Baden Create Conference in Frankfurt, Germany. And they co-presented together because Spring, Baden, and Java, it's like they all work very well together. But in the process of Josh's presentation, he made an interesting comment. If you ever heard his talks, you may have heard of David before. He said, and I quote, "There's never been a better time to be a Java developer and a Spring developer." And he gave his own reasons based on performance, based on speed, compatibility with being cloud native, his list of things. But after his talk, I thought about it, and I was like, he's really right. There's never been a better time to be a Java developer and Spring developer, because for one thing, today's Java is not your dad's Java or granddad or grandmother's Java. It's very different. It's been modernized. We just saw from Chandra and Rodrigo that it's a modern tool, right? It's been made to work with less verbosity, be quicker, be applicable to so many applications. And the same with Spring. You're seeing all of the releases come out. I like looking at the jets sometimes. Like, kid or candy store, like, what's coming out next? What are we going to get access to? So I agree with this statement. But Josh made another statement that I found kind of curious. We caught this on video. Josh also said, when it comes to Baden, Baden makes me drunk with power. The UI no longer frustrates me. I'm like, okay, I'm catching that one. Because we're talking about Baden, which is Java-based, and the UI. Whenever I travel around the country giving these presentations, whenever I talk to people about Java and front end, or Java and UI, I typically get one of two reactions. Number one is, Java on the front end, hell no. Or Java on the front end, yeah, we used to do that way back in the day. Nobody does that anymore. So let's handle those two objections as well. Let's handle the nobody does that. So, who is this? Please feel free to just yell it out loud. Duke, thank you. What is Duke? Duke is the Java mascot. He's the Java mascot, right? That's how we accept him now. But what was Duke originally? Duke originally was a small animated character that appeared on a curious mobile device that had a beautiful UI for the time. I think it had a touch screen, it had drag and drop capabilities. And it was a cute little animated figure that was like a software agent to work with you as you interact with this device. What was the name of the device? Whoever knows this is the teacher. Google it. Google it. Y'all are fall asleep on me. It's not lunchtime yet. Wake up. Google it. What was the device that Duke first appeared on before he was the mascot for all of Java? He was the mascot. He was the animated character for one particular device. That's the one time. It's very easy to Google. You can use your phone to check it. Use your phone to check it. It's a device. animated character on what device? True Jeopardy music. Star 7. Catch there. Everybody give him a hand. Everybody give him a hand. Thank you. Star 7, an innovative device. I'm not sure what ever happened to Star 7. It might make it past production. But this was a mobile device in the early 90s. It was a touch screen. It was a drag and drop. It was a beautiful UI. A beautiful front end. And that front end was built and enhanced with Java. From the very earliest incarnation of Java, Java has been working on the front end. Moreover, it was so early of an incarnation of Java that it was actually before Java was called Java. It was called Oak, named after the oak tree that was outside of James Dobson's office here at Sun Micro. Raise your hand if you can learn something. Awesome. So, what is my point? Java has been used on the front end since the history of Java. You may or may not know that, but it's very true. But what about this other idea? And that's the device right there. That's the Star 7. By the way, Duke was released in '95. Cute little animated character to help you with your UI. An interesting, similar character appeared in 1996 from Microsoft called Clippy. Who remembers Clippy? Duke was first. Shout out to John. All right. So that brings me to this curious symbol, which hopefully you can see it. I know it's dark. It's a reindeer, same as on my shirt here. The reindeer. Reindeer is native. Reindeers are real, by the way. They don't fly. They are real. They're native to Finland and that part of Western and Northern Europe. Finland is also the home of our company, Vaadin, and we've kind of taken on this whole reindeer motif, reindeer culture. But where does Vaadin come into play, and what does it do for you as a Java thing? What is it? Because I was on a podcast 2 weeks ago that said, all right, Vaadin is just Java on the front end. We have that, but it's more than that. And even at the Dallas Joe, about a month ago. I'm like, all right, this is Vaadin, a full stack platform for Java. Or full stack framework for Java. We said framework. You have that, but it's more than that. So what do you get when you talk about Vaadin? I want you to think about this right here. If you forget everything else that I say, and I hope you won't. Java should be the home for every Java developer. This should be just like home base. If that's your jam. If you do Java on a day-to-day basis, or you have that part of your tool set, it should just be home. That sounds like it. Specifically, if you're building business applications that live on the web. Business applications, data-rich, not just cute websites, there's other things that optimize for that. Actual applications, internal tools, dashboards, full SaaS applications. And Java is your jam. The first place you should check is Vaadin. Why? Here's what you get. You get modernization tools. We have part of our enterprise software and enterprise offerings. Some tools to get you from Java 6, Java 7, Java 8, Java Swing, anything old to get you modernized in a matter of minutes. We have modernization tools in this ecosystem. We have design tools. We literally just came out with a new tool that can take the design, import it into the UI, and generate the Java code from the design. This is part of the ecosystem. We have web components. Our web components are amazing. They're like the building blocks of everything that we do to build for the web. Robust set of about 50 web components, buttons, to text fields, to all sorts of things. And if you play with Swing back in the day, you might be somewhat familiar, but these are written in Java, they're modern, they're responsive, a robust set of web components. And in addition to that, we have, because most of our core offerings are open source and free, we have a thing called the add-on directory where there's probably 1,000 additional components for any particular use case you come up with. Oftentimes we'll have maybe one of our specialized components will be for a fee. People say, no, we'll just build it ourselves, get together as a community, and that's available to you open, free, and add-on directories. With those web components, we have the first framework I want to talk about. We offer is called Flow. That is 100% full stack development with all Java. The logic side and the presentation side. I don't want to say front end and back end per se, because Java is always back end, it's on the JVM, but we're going to generate that front end code, right? Generate the HTML that's going to be displayed in the browser from that back end language. You just write it all in Java. I'll show you an example. You have the accessibility tools to make sure you're doing everything accessible, the idea of accessibility. You have testing tools, modern test bench, do UI tests, both unit tests and integration tests. We have that tool for you. In this ecosystem, we have a brand new AI coding system, our own Copilot, where you can code and we'll see it in the UI, and you can drag and drop in the UI, and it will generate code in your editor, There is internalization tools. There's a second framework called Hilla, which is a meta framework that is built on other tools. So imagine Spring architecture with the React front end, and it's bundled together in a single platform. Now you might work somewhere where you already have React and Spring Boot, and you wonder, well, why do I need this? This has been configured to handle the communication layer for you. It literally abstracts it away. I'm going to show you an example of that in just a few. You also have deployment and automation tools. We just came out with a control center to help you do your deployments through the Kubernetes clusters. An active community on our forum. Overall, the product is, you see at the top there, a full stack platform. Not just a framework, but an entire platform. Like I said, a home for Java developers. So in terms of the workflow, this is a little more theory than I usually do because of the sake of time. If you think about workflow, you start here, the business requirements. When I worked at FedEx, we always called it the business. And you can't just say you have to use your hand like that. So yeah, the business. Like they're over there, the business, for the developers, the architects, but the business. But we need them, kind of. So it starts with business requirements. Hey, can you guys make a blank? And they send those requirements over to a team. Now imagine it's a full stack Java team. A full stack Java team. That's what they do. Their core language and ecosystem is Java. And we're saying is we can help you build that app, whether it's an internal tool, SaaS application. We can help you build that with this right here. This is a simplified version of that former slide. You can take the Figma design or legacy Java. You use the modernization toolkit if you need to. Use our AI coding assistant. Our two different frameworks, Flow or Hilla. I'll show you which one to use and when. A robust set of web components. Control center you can use out the door. All packaged into your home base. And I'm even looking at now individual Java developers. We have one at FedEx in Atlanta. You heard the presentation. He's a Java developer. He hates building the front end, and he has to because people don't like working in general unless they're developers. And he had a client, and within the next conference, he saw me. The next tech he saw me again at DevIgnition, which was also in Atlanta. He had built a full stack application for a client, sold it to him with a logging system. Some little warehouse developer. He sold the complete application for the whole thing front package Java, and he loved it. So he loves it. This stuff does work. Next slide, control center. I mentioned the control center. I'm just going to fly through this, but it's brand new. I'm going to make sure I highlight it. Our control center does offer deployment options, managing options for Kubernetes clusters, monitoring for health, security, performance, logging, as well as user management and reviews right there. So when do you choose what? The left side is traditional. This is what you're used to. This is what I'm used to. This is what we did at FedEx. Right? You might have components, you might not. But you have a front end that's very often React or Angular. You know, some back-end logic is happening, some service layer, some data layer, of course, as well. But in order for these to work together, you need this communication layer. I have a whole talk on this in the gallery next Monday. But you have to have those connected in some way. Right? So that's the most control. That's the most granular level of control that you're most used to, but it's not that efficient. If you get a little more efficient, we see Next.js, which is a full stack approach. And then here we come to the two bottom offerings. These are two offerings that we have. Number one called Hilla, Spring Boot backend, React frontend, still build the same components. And the Hilla framework will connect these two for you. I'm going to show you that. I know I keep saying it, kind of in a theoretic way. Stay with me. And then finally, if you need to be the most productive, be the least control, but the most productive, get it done the quickest, our option is bot and flow. The whole thing is just Java. Front to back, top to bottom. All right, so that's my cue to go to code. I have 14 minutes left. And by the way, I'm very easy to access online, so any questions, I'm going to ask y'all to table them either after the session or just catch me online because I think I'm the last session before lunch. No, I'm not going to have you beat me up because we're going to get to the turkey sandwich. Just hold tight on the questions and we'll get started here. So, how you start writing that? You want to start today. You want to go home because you have a project in mind. You're a Java whiz. Front end is like, I'll do React if I have to, or I'll do Angular if I have to. How do you start it? Start.spring.io. You've been here 1,000 times. You'll select your metadata as appropriate, and you'll use dependencies, and simply add body. You do have an official dependency with the Spring initializer. You'll start it right there. You might want to add dev tools if you want to. You can also add your Spring data. You would add all your Spring things, your Spring modules as you normally would. But the main thing you want to add right there is the body. And we also have our own initializer. I'm going to show it to you just because I should. And it looks like this, where you can start a project in a drag and drop way. Okay. choose the thing, you can start it that way, or you can start it here, which is similar to the initializer. You will choose your architecture here. You're going to use Flow or Maven or Spring Boot. You choose your framework, whether it's Flow or Hilla. You see we do have lit support as well. Language can be Java or Kotlin technically. Build tool can be Maven or Gradle. I'm a Maven guy. And then architecture can be any of the ones down there. And that will get your starter project. When you generate the starter project, this is how it works. And I'd add a minimal amount of code here. This will be Hello World in a bottom flow application. That is way too small. Better? All right, cool. Here's Hello World. Not much here, but here's what I want you to be impressed by. In this single Java class, no React, no Angular, no front end, no HTML, no CSS, anything. I have the routing where this view is going to show up. I have a very regular Java class, like you've done 1,000 times. Public class, home view. It extends some curious thing called vertical layout. Vertical layout is a bottom component that is going to organize your components vertically. Accordingly, we have a horizontal layout, we have a app layout, form layout, lots of different layouts to automatically position your components for you. Within our constructor here, we're going to add an H1. You should think, wait a minute, you said no HTML. This is a bottom component. Most of your popular bottom HTML elements, you have an equivalent bottom component. So you don't have to leave context ability and go to my HTML file and do this. You come to my Java file and do the whole thing right here. We're adding a new H1, we're adding a new paragraph, that's also a component, and we're adding these two strings. This add method is going to add it to the constructor, and there's not many imports, I will show it to you, so we'll look up my sleeve. We imported the components, H1, paragraph, layout, and the route. We'll go ahead and hit our play button. And this is going to generate a local host here. Internet will cooperate with me. It's good so far. Okay, there we go. So welcome to your new application. So that's just a string. So cool. So no big deal there. Only thing I want you to be impressed by here is that there is no HTML file. We're generating from the back, full stack from the back. We're generating from the back to the browser, basically using the browser like a thin client, letting it know what should be displayed and where. On that initial page, you get just the lazy loaded HTML that you absolutely have to have. And then with every user interaction that gets sent to the JVM, you get updates specifically back to the front, back to the front. Let's look at something that's slightly more impressive. Let me open up my combo app. Let's just select it. All right, so source name, Java, views. All right, so again, so nothing up my sleeve. So when you're building a modern flow app, again, you do all the normal Java things or Spring things that you would never normally use. In this case, I've pre-written a contact service, a CRUD service. There's nothing bottom specific about those. I'm just gonna run through that. Push service as well. I just want you to see there's no heavy lifting happening here from the UI perspective. We also have our data model, so I have a contact data model, repo, this extending JP repository, and database initializer because I need some data to work with for my demo, and I know that's heading off. Hold on a second. That's still visible? Is that okay? Take that as yes. All right, awesome. So from there, let's look at what Bob is going to do for us. Let me go to my grid. All right, very similar to the Hello World. Very similar to the Hello World. I've got my class called Flow Grid here. In this case, it's going to route to /flow-grid. My routing is taken care of. In my constructor, I'm going to take the contact repo. So that's a repo class, just like you would normally do. That's what's getting access to my data. And here's where it gets interesting. I'm going to add an H2, no big deal there. Var grid. How often do you need a grid in control applications and tools? All the time. We have a component called grid that gives you a grid out of the box. No heavy lifting whatsoever. All I need to know is what data model am I using. So in this case, I'm using the contact model. In order to add columns from our grid, I simply need the add column method. I can add as many of those as I need to. You know exactly where to get each piece of information from. It's going to go to the contact model. Use the getters. I'm on the back end, getters and setters. So I use the getters from that model in order to get the data. Set my header names. And then in this case, so I could have done either method here. So this is just setting the item. This will work. So this also works as well because it can use the embodied Spring Data Helper to make this lazy loading. It's going way off the screen because it's so big. That's using that Spring lazy loading. So I can query that and just string it in. In case you have like thousands and thousands, you don't want it to make that first hit and actually try to pull all the data at once. You want to string it continuously. So that page, good. Incredibly. So that's how that looks. That's the grid. All right, let's do one more. Then we're going to go to the hillside. I have 7 minutes. The grid. I don't want to do it. Let's take that back. Let's just go straight to. Let's just go straight to the hillside. So full stack Java, call it Flow. It's just that simple. We have a demo that I can show you real quick. Built 100% in Java. Code's not available yet. We're still working on tweaks of things, but people like to say, well, what does it look like full blown? Like, what can this actually do? And it can do a lot. So this application here is built 100% in Java with our Flow framework. So this is an imaginary, interplanetary looking application, but the elements that it uses are things you use all the time in the tools, in the dashboards, in the SaaS app that you make. So having a list of users, having a list of locations, and having different columns, being able to search, being able to sort. Go over here to the booking side, you can see a nice list here, nice professional clean. Our app comes with an internal theme called Lumo, L-U-M-O, for easy styling. It has its own classes and things for that. We do all styling in Java. But again, this is in the browser, so if you're just dead set on using your own CSS, you can absolutely do that as well. Yeah, you see the upcoming here. We have all these different flights to different places out in outer space. A nice list of customers. I think we even have a support page. This is a very common use case, having a support page, having messages coming up, you know, to get a message. This entire app we're looking for right now is living, working on body flow. That being said, earlier I mentioned React, and I mentioned the fact that we also have a meta framework called Hilla that combines Spring Boot and TypeScript reactive in a single project. And look at a quick example of that. And this will work as well. Let's look at this. This is a, how many React people do we have? Even a little bit. One or two? All right, cool. So, basic functional component here. What is relevant about this I want you to see? I'm returning something called autocode, which is one of our components. All of the components that you'll learn on the Flow side, the Java side, we have an improvement on the TypeScript side. So I want to just return that component, and I want it to reference CRUD service. Remember we looked at CRUD service earlier? That's what I wanted to reference in terms of the methods. The model I want to use is the content model, and I got a class name here for styling purposes. That code right there, that's like 4 or 5 lines of code, not including the imports. That code right there is this grid, which I think is a pretty common use case. It is auto CRUD, it has the ability to filter, to sort, out of the box. You do have some scaled down as well, so you don't want all the filters, you don't want all that heavy lifting done for you. You can't have this plain grid as yourself. And we find this is a very, very common use case. You're going to store the grid. This is the same data that I mentioned earlier from the database and just like everything you see right here in this front end generated from this right here. Now what's really interesting, let me go to, let me show you where it is by the way. So now this down here in Java, that's the Flow side. Here in the front end package would be the TypeScript side. Let's do this one. We're going to have 4 minutes. All right, similar grid, but here's what I want you to look at. This again is a TypeScript function, which you've probably done that before. Here's what's relevant. Look at that signal right there, line 13, contacts. All right, so we have a contact, it's a signal. We're initializing it with an empty contact array, nothing crazy so far. Contact is our data model, an empty array of those. Then on use effect, we're going to do something really curious. If we're React person, something very curious. I'm saying within my use effect, I'm going to call the contact service class, which is a Java class, and call the find all method, which is a method in my Java class. No React, no GraphQL, I'm just literally directly calling the Java class, so to speak. And then from that, I'm going to update, so whenever the value of the contact update is going to update that empty array, and I can populate that down here in my grid. Contact value, the same contact value. And that's how we populate that grid. But the most important part here is line 16. I can't emphasize this enough. This is React, grid.tsx, TypeScript. And I'm calling the Java method, the Java class, the Java method. How is that possible? Well, that's possible because the other framework, close this up real quick. Find my classes, contact class. Line 10. That annotation browser callable is magic. This is my Java class. In the Hill application, whenever you add that annotation browser callable to a Java class, once Spring scans all of your files, it will generate on your behalf a TypeScript interface that is type safe and contains all the methods available for the front end. Everything that's in there is immediately available. Again, no REST API, GraphQL, or any other communication layer that work that you have to do for yourself. So every method here that I've written in Java, I immediately have it available on my front end. In a similar manner, if I define model data on the back end, it's immediately available for validation with forms on the front end. You don't need any front end work. As long as it's done in Java, again, full stack in the back, generate that for you in that front end. So with that being said, code, what's left? Some new things we've had recently, and we're going to flow through these in the last minute. We've had signals added. We have Hilla and Flow together. Those two frameworks, you can now interchange them if you have need for that. We have automatic menu creation. I talked about Copilot already. Automatic flow layouts. We have components in React, so you can use flow components in a React file. Some new features in our design system, the control center I talked about earlier, and initiatives for next year. The new thing, we'll talk about the little thing and the new thing coming out, the Aura thing. Many more components, full stack signals. I don't know who's working that right now in Java world. Full stack signals coming out. Seamless continuous and deployment part of our control center. Additional monitoring features, preview deployments, full stack AI components, and more code generation options. Maybe. So, I am Lawrence Decodes on pretty much all platforms, like Young Senator said, on my hard time. So whether you use Twitter, YouTube, TikTok, wherever you are, just look at Lawrence Decodes, you'll find me. Happy to interact with you and help you out. Found this to be an amazing platform for individual Java developers as well as Java teams who work together. Thank you.
So are there any questions? We do have time for a few questions, so let's not be shy and ask our Batman from Memphis. That's going to live rent-free in my head forever.
I'm rolling with that.
Any questions? I know we went through a lot quick.
Here's one. That light is blinding.
Are you using this new tool or platform in your current job, or you just learn outside of it?
Good question. So I am, because I work for them. So yes, I've been a developer advocate at Bottom, started working there last year. Now, prior to that, it's a great question you asked. I was actually a developer with FedEx for 4 years, working global hub and sort team. All of our applications were Angular and Spring Boot, or Angular and Java. So Valve does not have Angular support currently. Again, this is open source though. All of you who are participants is open source. We encourage you to check out our GitHub, help encourage what's going to be the next features. We've optimized for React and Spring Boot, but there are some tools that languages you see. Now, to answer your question even more directly, before I worked for Valve, I had never heard of them before. What I knew is I wanted to deal more with the community and do it in the Java ecosystem way, because there was just a very limited number of companies that had openings when I was applying.
It's a good answer. Any other questions, or are we all just waiting? All right. So on that note, we'll release you to the wild for lunch. Everybody, please be back here at 1:30. Farouk's going to be coming in. He's coming from Gradle, and we'll be giving the next talk after lunch. Yeah, very cool guy. So you're in for a treat. But thank you so much for staying with us this
Thank you.
morning, and thank you, Lawrence, as well, for being here.
I didn't do my mandatory picture. What was I thinking? 3, 2, 1. Awesome. Bye, y'all. Run. Arms wide.
My neighborhood was like really fun.